Section 9.1, Inferences for Regression, Video 4. In addition to estimating the slope of the population regression based on the slope that we obtained from the sample regression, we can also test whether or not the population slope is equal to 0. Truth be known, we can test anything we want. Is the slope equal to 0? Is it greater than 0? Meaning a positive association. Is it less than 0? Meaning a negative association. Is it greater than 2? Is it less than 15? Is it greater than -5? We can actually test anything we want, but we'll focus solely on testing whether or not the population regression slope is equal to 0, because if we do conclude that the slope is equal to 0, or more specifically, if there's not enough evidence to conclude that it's not equal to 0, then that means that the explanatory variable is not an effective predictor of the response variable, and hence we shouldn't be using it to try to predict values for the response variable. For example, on page 580 in the printing speed versus price scatter plot for printers, we're going to test if the printing speed is an effective predictor of the price using both the critical value approach and the p-value approach. Now, both of these start out with hypotheses, so we should start there. So if we're testing that the printing speed is an effective predictor, would that be the null of the alternative? Well, look at the red box. If the slope is equal to 0, then it's not an effective predictor. Slope is equal to 0 would be the null hypothesis. So this hypothesis could also be stated that it is not an effective predictor. And of course, the alternative would be that the population slope is not equal to 0, which means that it would be an effective predictor. So you can state these hypotheses either in terms of words, the effectiveness of the explanatory variable as a predictor for the response variable, or you could state them numerically in terms of the slope being 0 or the slope not being 0. Just keep in mind that slope not equal to 0 means effective predictor, slope equals 0 means not an effective predictor. Now, if we're going to do the critical value approach, then we need a critical value. Now, I haven't given a significance level, so we're going to assume it's 5%. Two-tailed test, because this says not equal to. So two tails. 5% gets split in half among the two tails, so 2.5%. The degrees of freedom is still 18, so we're going to get the exact same t-values that we got before, plus or minus 2.101, which if you were paying attention, you may have noticed never mind, I was going to say that the t-values in the computer output, but that's not what the t-value was. The t-value in the computer output was the test statistic. Speaking of the test statistic, there is a formula for it. The formula for the test statistic is what you get from your sample minus what you get from your hypothesized value from the null hypothesis. So in this case, what we get from our sample is B1, and what we're hypothesizing is 0 in the null hypothesis. So writing B1 minus 0 is silly, but if you look on page 579, it actually starts out that way, divided by the standard error. The slope from the sample regression from the computer output is under the coefficient column. Remember, the estimate column should say coefficient, and it's in the second row, and it's 90.88. We're going to subtract 0 from that, so there's no need to do that. The standard error also from the second row in the computer output under the standard error column was 19.49. And if you divide that out and take it to, let's go ahead and take it to 4 decimal places. Still going with 4 decimal places unless we're told otherwise. 4.6629. If you go back and look in the computer output, the t-value in the second row is 4.663. So that's where that value came from. And what decision do we make based on that? This critical value falls to the right of, this test statistic falls to the right of this positive critical value, falls in the rejection region, which I didn't label before. And so our decision is to reject the null hypothesis. And what conclusion do we draw? Since we reject the null hypothesis, we're accepting the alternative in its place, which means that it's an effective predictor. And we can just say effective predictor for the sake of brevity, since the context was already established up here. So that's if you took the critical value approach. Well, what if you took the p-value approach? Well, the p-value for testing if the slope is equal to 0 is the p-value given in the last column in the second row of the computer output. And that p-value was 0.000193. And remember, if the p-value is less than the significance level, which in this case is 5%, and it is, that implies that we reject the null hypothesis and draw the same conclusion. It's an effective predictor. At this point, you may be asking yourself, why bother with the critical value approach? If we're given the p-value, the hypothesis test is over just as soon as it begins. And you would be correct. I still want you to be familiar with both of them, because nobody said I have to give you the p-value, or even I have to give you the test statistic. In other words, in the computer output, I could just give you the predictor column, the coefficients column, and the standard error column, and ask you to take it from there. So I still want you to be familiar with the test statistic, the critical value approach to a hypothesis test. But there will be some questions where I ask you the p-value approach, and it's going to be really, really easy.